In this video, we'll be understanding equations of motion from first principle so that you don't need to cram them, you will need to understand them and be able to solve all problems. So let's start by understanding some basic terms. The first is what? Distance. So distance is the total length of the path covered. That is, how much ground you have covered. So distance has to do with if you travel, for example, if you travel from here to here, distance is measured in meters. So let's call here 5 meters. If you travel from here to here and then go back to, let's say, 3 meters. All right. Now the distance is the total ground you have covered. That is from here to here to here. So that means 5 plus 3, so you have traveled 8 meters. So distance is always positive because you are not concerned about the direction. You just want to measure the total ground that you have covered. The second term to know is displacement. Displacement simply means how far you are from where you started and in what direction. So you notice that displacement has to do with direction. Some people will call it the change in position. All right. So using this same illustration, if you start from here, move like this and come back here. Now your displacement is, this is your final position now. This is where you started. So your displacement is from here to here. Okay, so what will be our displacement from here? It's going to be what? 2 meters from here to here. So displacement has to do with directions, whereas distance is just the total ground you have covered. Speed is simply distance covered per unit time. That is how fast you are moving. Here, no direction is involved, just how quick are you moving. That's what speed is all about. And the next one is velocity. This is displacement per unit time. That is how fast you are moving and where you are going. So this has to do with direction. Please take note. Some person can say that velocity is speed plus direction. That's actually true. So you will notice that speed only tells you how fast, but velocity tells you how fast and where. You need to understand this. Now the next term you need to know is acceleration. Acceleration is your rate of change of velocity. That is how fast your speed or direction is changing. Okay, so acceleration just means how fast velocity changes. Let's say you are driving with a particular velocity, that is your initial velocity, and now at the end you have another velocity. How fast did this thing change? That is your acceleration. So mathematically, you can say that acceleration is your final velocity minus your initial velocity. How fast? So it has to deal with time over time. All right. So from here, you can, if you do the mathematical manipulation, you can multiply both sides by t. All right. So that this implies that yes, at is equals to v minus u. All right. If I make v here subject to the formula, I'll have that u plus at. So let's call this equation 1. This is the first equation of motion you must know. So here, v is what? V is your final velocity. I hope now you know what velocity is. U is your initial velocity. This is the acceleration, and this is the time taken. All right? So we'll be using this to derive the rest of the equations. So the symbol does not matter. Some textbooks might call here V naught. All right? Some might call it VF and V initial. Anything. Just understand that this is your final velocity. This is your initial velocity. Now recall that we defined velocity to be displacement per unit time. that is displacement divided by time. That is what the velocity is. So if I make displacement subject of the formula here, we are going to have this, all right? But you need to understand that the velocity we are talking about here is not constant. Why? For us to have acceleration, that means velocity is changing. Okay, so the velocity is not constant because there is an acceleration. So which velocity are we going to use? We are going to use the average velocity because there is a final velocity and there is also an initial velocity. So average velocity, what is average? Average velocity simply means the initial velocity plus the final velocity all over 2. That's how to find the average. Okay, so now let's write the equation for displacement. We used s. So displacement x now is going to be this average velocity, which is u plus v over 2 times time. Alright? But we have defined v from our equation 1 to be u plus at. So if you substitute this value to this equation, substituting this to here, we are going to be having s equals to u plus, anywhere we see v, we are going to put u plus at. So we are going to have u plus at, all right, over 2 times t. So if you open this bracket, you're going to be having s is equals to ut plus half at squared. So this is our second equation of motion. All right, here now where x is your displacement, that is your change in position, this is your initial velocity, this is your acceleration. But when motion is in a straight line, that is, there is no change in direction, this displacement can also be distance. Please pay attention here. When motion is in a straight line, your distance is equals to your displacement. So that is why it can use this to find distance when motion is in a straight line and there is no change in direction. Now, from v equals to u plus at, if I make t subject of the formula here, I'm going to have v minus u over a. All right. If I put this into this equation, if I put this into this equation, what are we going to have? Let's see. So we're going to be having s equals to u plus v over 2 times v minus u over a, right? So we have s is equals to u plus v over 2 times v minus u over a. Okay, so this is equals to u plus v minus u over 2a. Now mathematically, remember, if you have a plus b, a minus b, you know this is equals to a squared minus b squared. All right, so this implies that u plus v minus u is equals to what? V squared minus u squared. Another way you can do is that if you open this bracket, manually, you're going to arrive here. All right, so now our equation becomes what? V squared minus u squared over 2a. All right, so from here, mathematically now you can, anyhow you want to do it, I can have 2as is equals to v squared minus u squared. Okay, if I make v squared subject of the formula here, I'm going to be having u squared plus 2ax. So this is our third equation of motion. So from here, you notice that this is your final velocity squared, your initial velocity squared, your acceleration, and your change in position, which is your displacement. Okay, so with this understanding now, you can be able to solve all questions on equations of motion. So in the next video, we'll be solving practice questions. If you have gotten value, please like, comment, and share. And make sure you subscribe to our channel so you don't miss our videos. See you in the next video.